because a lot of times you'll see stuff where they'll get hung up. And then you might have not serviced that system yet, and the person before you zip tied it to some weird thing, and it's like wrapped around something.
Yeah, majority of the issues that you're going to run across probably in a pit are going to be related to floats, right? I mean, these are going to be the things that are going to need the most attention, outside of the pump itself and whether or not it's clogged. A lot of the issues are going to come from the floats. So we'll definitely spend some time talking about those today. So basic kind of application, the whole point of these things, anytime you have drainage or fixtures below grade, like where you can't gravity drain away from the building, you're going to have to collect it and pump it out with these, right? So it's going to be either storm or sanitary. Storm is somewhat clean, and then the sanitary is going to be anything after use. So fixtures, grease traps, anything like that's going to be sanitary. So really the only difference for us in terms of storm or sanitary, like either one of these pumps can be used in either one, is how we're going to typically do the floats. On a sanitary pit, we really want to have less floats so that we get to that high level alarm faster. And we'll talk a little bit more about that when we talk about the float switches. And then, we want to make sure that those systems are serviced regularly, right? That you guys are in there making sure those pumps are working, because definitely don't want to have high level alarm issues with a sanitary pit. So on the storm side, we're going to be moving a lot more water in, but potentially, and that's where we get into the 4 float switches, where we might need both pumps to run before we get to the high level water. So the kind of the 2 different setups that we have here, this would be kind of our quote unquote Spartan system. So this would be a little bit smaller pumps, kind of the entry level float switches, and our entry level panel. And this panel is really kind of, I would say, what's typical out there for a sump pump panel, meaning it's got relay logic and it's a pretty simple system. So if the panel is out there and it was not provided by Cougar, it's likely that it's going to be these types of components. Okay, this is our Elite Series panel. This is the one that we've designed and developed over, I don't know, almost 20 years probably, of feedback from, like my dad, Scott, EJ, our service tech salesman, being out and working on panels and just all the little things that they've seen, all the issues, that type of stuff is built into this one. So there's a lot of extra features in here, a lot of extra safety devices that don't exist in these types of panels. So obviously there's a price difference between the two, right? So there's going to be times where this might be the right fit for your customer, but there's a couple of things that you're going to want to point out that on these types of systems for y'all for troubleshooting, and just for you to know for your customers, kind of what you get with this type of system.
Does that one have like where you can change the amps, like for the circuits and stuff?
Yeah. So they all can do that. So if we look at the panel itself, we kind of go through, on these types of panels, we've got, and so there's only 120 volts in here. So if I'm pointing around, please don't do that out in the field. Stick your fingers in there.
Oh, come on, man.
Yeah. But so in this panel, we organize them with the high voltage on one side, the 3-phase on this side, and the low voltage, the control on the other side. So this is going to be the same way. You'll see that kind of separation of the power in the panel. We do have a main disconnect switch here inside the panel for the incoming power. A lot of other panels may or may not have that. So if you don't have a main disconnect inside the panel, you're going to need to know where to be able to shut off the power, before it gets into this panel. And just because you're able to shut it off here, you still have live power coming in underneath.
Yeah.
Okay, so that does allow you to make the rest of the panel safe, but there still is high voltage coming in. So just be aware, even when you have a through the door disconnect like this, if you're not shutting the power down ahead of the panel, you still have high voltage coming in. Okay. So off of the disconnect, we're coming over here with a high voltage, and this is our motor control circuit. So we have a combination. This is a manual motor starter here. It acts as your circuit breaker or your disconnect there, as well as the overload. And then down here is the contactor. This is the relay that's pulling the motor in, the power in when we want to run the pump. So this is where you have the ability to adjust the amp range.
Yeah.
And so you're going to match that to the full load amps on the nameplate of the motor.
Yeah, not below or above, right?
Right, you just match it. So it has the safety factor built in. You just dial it into whatever the rating is on the nameplate, and you'll be good. And so depending on the type of the overload, it's gonna, depend how long it has to run over that amp draw before it actually kicks out.
Now, I usually look at those plates, but what am I looking for in terms of what you just mentioned? Right?
Amps. Just amps, bro.
Yeah, but where's he gonna match the
It's
amp
easier to
at?
see on the. So on this one, this is not the right pump for this panel, but it says right here
But normally
FLA,
it's 10, and it's 12.6. That one's 12.
so full load amps or FLA is what you're looking for, and that's what you're gonna dial this in
I got you.
to match.
With
So
the
there's
driver?
a
See that
little
tape?
dial
It is
here.
screwdriver.
Over here. I see it goes up. Okay.
Turn
These
this
pictures.
I got you.
to match.
Where?
Right,
So we'll see it. We have a different style on this one.
Oh, key.
Yeah. So this pump doesn't match with this
I don't
panel,
know that.
but it actually ends up being the same range. So these types of overloads typically have a pretty tight range. So if you are changing pumps without changing a panel, you need to make sure that the new motor full load amps is within the range of the overloads. If not, you're gonna need to change out the overloads. Sometimes these are almost, especially in some ranges, they're really tight. They can almost be horsepower or pump specific. So really got to make sure, because a 7.5 horsepower motor from Grundfos and from Myers or Wild or whoever else may have different amp draws. So just because you're changing out horsepower or like for like on horsepower, the amp draw may be different.
Let's say that we're inspecting one and it wasn't at the right one. What would that cause the pump to do?
It won't
It's a
work.
great question.
Well, let's say if it's lower than your amps. So say you're 12.6 there, but you're not 12.6
How would
there.
you like just like off the bat, like all right, that's what that is.
So if you
It's like looking at it.
sometimes when you buy these pumps, they come with a sticker and you can put it on the inside of the door and you can see what it's supposed to be, if that's the same
That's
as
what
what's in
that's
the pump.
for?
Yeah.
No, that's
So otherwise, you pull it and look at it, but if you don't have the overload set to the full load amps of the pump, if it's above it, then you're going to be running the pump overloaded without it tripping, right? So you're not getting that same burn.
So it could potentially damage the pump if you set that too high.
So if it's too low, it's going to trip out early.
I didn't know what it said. There's no like number on it or.
There's a little arrow, little arrow right there. So it's pointed at 11. It's pointed at 11. Right? So if you had a little screwdriver, you could.
Okay.
Contacts.
Mine straight on the side.
Yeah.
Thank you.
Yeah, right up here. So yeah, if you want it dialed into whatever it is on the nameplate. Yeah, otherwise it's either not going to trip or it's going to trip too early. But if it's tripping immediately when you try to run the pump, that's probably an indication of the direct short. So either inside the motor or in the wiring.
Right.
Or something stuck in there, right?
Well, so direct short would typically be that there's either it's going to ground somewhere. So either inside the windings or in the wiring between
Yeah.
them.
So when it's got something stuck, it takes a little bit before it trips the breaker.
Right.
Yeah.
So if it's got something stuck, then the amp's going to overload, and then depending on how much it's overloaded, it's going to depend on how long it takes that to trip. Anything to add on to that, EJ?
The overload is a heater. So if it's over ramping, it's going to take maybe about 3 to 5 seconds for it to heat up, and then it'll trip. But if it's grounded, there is no weight. As soon as you turn, it'll snap.
Put it automatic.
So that's indicating
water.
that's an issue with the motor.
We're gonna find the wire at.
Where will you find it? It's never on the wire. It's
No.
on the motor.
We're getting wire. Where would I get it from?
No, that's what I'm saying. There's no wire. It's the motor. It's the windings in the motor.
Because we had a problem with that day. I pulled out 100 feet of wire and go through the cable
Yeah.
on the ground that was broken.
Okay, you're talking about an extension. They had a J-box
No,
and they ran wire.
George, let's get back to that. Let's continue. We'll get back to that.
Yeah. No, I mean,
Yeah, I understand. We'll get back to that.
no, that's a potential. Yeah. So, so below the overloads are those contactors. Those are what's pulling the motors, or giving the power to the motors. We go on this side. We're running two of the legs of the high voltage through control transformer, and we're knocking that power down to 120 volts, and that's what we're using for the control system.
So this is the transformer here?
Yep.
Okay.
So there'd normally be fuses behind the plastic. So if you have power coming in but you don't have control power, checking those fuses is going to be a good place to start. And this is not a good demo panel because usually we have spare fuses hanging there so you can replace those. Okay. Underneath that we've got our alternating relay. So this is what's going to switch the pumps every time we go through the sequence. And so you want to leave that on alternate. If you force it to one or the other, then it's going to always run that pump first. So if you're doing service or something, you need one pump to be the lead. That's how you can do it, is use that alternating relay. Okay. So with this type of panel, we are sending 120 volts out to the floats. Okay. With a panel like this, we're only going to be sending 24 volts, just because it's coming off the PLC and not.
Is there ever a time to run both pumps at the same time? I take it with storm, you do it, right?
Yep. So hopefully with sanitary, no. With storm, there is that potential. Okay, so these are going to be pretty straightforward panels. There's not a lot of electronics or anything going on with them. They're typically going to be set up for 3 or 4 float operation. And one of the big things with any of these types of panels on the floats is the first float switch and the last float switch are important in this sequence. So if we're talking about 4 float switches, this is your all pumps off, lead pump on, lag pump on, and high level alarm. Okay, but the whole sequence has to start with this one. So when this one comes up, it allows everything else to happen. So now you can see that pump's turned on, but it's going to stay on until this goes down.
So then it does matter where you zip tie it.
The order matters. Yes.
I'm just throwing that out there. It doesn't matter where you zip tie it.
So the pivot point is going to be this weight, right? So that's where it's going to swing. So with these types of floats in this configuration, you don't need a big swing, right? Because you're separating out when the pump turns on and off into 2 separate floats. So the pump down range is going to be the difference between these 2 floats. Okay? So the longer you can get, the better. The pumps typically don't want more than 20 starts an hour. So the most pump down you can get out of the pit you want, especially if you're using the grinder. And you no longer pump down with the grinder.
I like what Angel said there just a second ago when he talked about zip tying it off. That doesn't matter. Okay, so pay attention to when you are zip tying off your floats. But really, your point of this functionality of this float is really at this weight. Okay, so wherever this weight sits at, if you got your weight sitting too far up, it's not going to pop up. You make sure this weight's set at the right angle down at the bottom. Zip tying it, just securing it to the pipe, whatever section you're securing it at, and then this weight. Make sure that's set at a good spot. You see how it's angled up here? Yeah. Right? So this one will pop one, this one will pop one, this one will pop one. Exactly.
On that note, if you don't have a weight, you do tie wrap.
Yeah.
But if you do have a weight, you don't, because it's maintenance.
Yeah.
You won't have to crawl in there to cut the straps off.
Correct.
So highly recommend all those weight.
Well, see, because I've been to some, I put up on a job that we haven't been to yet. It's a new job. And I go and there's no weights. But I'll see this one zip tied here, and then this one zip tied here.
Oh yeah, that's not
And it's like, dude, what are you doing? Because, like you said, it has to activate each other.
Did y'all get that? So this one was zip tied all the way up here, and this one was zip tied here. Now this is acting like your first flow.
And then it won't turn on because it has to turn on in the right order.
Yeah.
Right. So if this one was zip tied up there and it was going to wait till the water got up here, and this one tries to go up, you know, the pumps aren't going to turn on. Either is this one, and then all the way up to the top, you're going to get your high level alarm before anything happens.
And these don't really act anything like this. Okay, so they're going to float on top of your water at a level position. They don't start acting in until you put it up. So you give it that option to pop up there. But level doesn't work. That's why you have to zip tie it so that this cord will pull it down and get it up like that. Okay.
So one thing on the high level alarm. On this one, you notice it's just an alarm, so nothing else is happening. So on this one, when we do the alarm, remember how many floats? It brings on the pumps, right? So the way that we build these now, it does bring on the pumps, but most other panel makers don't. So basically what that means is you don't have any second layer protection if this float fails, right? You're gonna get that alarm, but you're still gonna have a full pit.
Basically, it means always get Cougar.
There we go. Like that. But so it is just something to be aware of, that the high level alarm here typically is not going to turn on pumps. It's just going to be an alarm. So if you get an alarm with these types of panels, you really want to try to address it ASAP. Okay, so testing for this bottom float and this top float, making sure those are working, is going to be critical. Okay, so that's anything else to add on these types of panels before I move on?
Just on the floats, like you say, normally you got companies that do the full float system, and the ones that do the maintenance is y'all, or the work. So you never want to show up in the pit full of crap. You want to be able to pump down all that. So instead of doing that off on lag alarm, do the off on alarm, then the lag. So if one pump fails, it gets locked up or whatever, it sends you an alarm to let you know that there's an issue, but you have still the second pump to be able to pump it down. Because on that normal standard, you won't get an alarm until both pumps are locked up.
Yeah.
So you want to make sure you get an alarm before, and that's how we do that.
That's what's up.
Yeah, so you can put them in a different order. Like you said, you can put the high level alarm before the lag pump. So if it's a storm pit and it sometimes can happen that both pumps are going to run, they may see that as a nuisance alarm, right? But it's still good to get.
So to be a little clearer, you would adjust this float differently, right? So if you want this float, this is your pump 2 here, this is activated on, this one's coming on, right? There's your second stage, second step there, and then you set this one lower so that this one will activate before your pump 2 comes on, right? So it's on, pump 1, alarm, and pump 2.
So then, doing it like that, it won't piggyback each other then, right?
No.
That second pump's always just the emergency, like, oh crap.
Yes. Something happened to the first one.
Yeah.
So whenever you show up, it's like, how did both pumps fail at the same time?
Yeah, correct.
They never fell at the same time. The problem is it's always been working on the
Has to
second
be
pump.
one.
Nobody knew about the first one, that locked up.
Yeah.
Now you show up and they're both locked up. But that's the most common question by the customer. How do they both mess up at the same time? They don't. They just, nobody keeps an eye on them. Nobody sees it until.
Too late. Right.
That's good. I like that.
Yep. Any other questions on that one before we move on to this guy?
This is basically just a warm up. Right?
Yep. Yeah, this is the
That
like a
allows-
primer.
that
I mean,
allows you to
this
pick
one
on it,
has
right?
to go up.
Okay.
So it's a holding circuit. This one starts the process, and then everything else is based.
Right.
Make
Follow
sure
up.
it's smiling at you.
Yes.
Yeah.
Okay.
Yes.
You can't really play with shit.
So when we jump up to this panel, this is our Elite Series. So you notice right off the bat, you get the touchscreen on the front. This is going to give you the feedback of everything that's going on in the system, and you also get a through the door disconnect. Okay, so this allows you to turn off power before you open the door. Remember, you still have that hot power coming in underneath. These switches right here don't exist on the real panel. They're just here so that we can act like we're flipping float switches without having to flip float switches. Okay.
That's what's up.
Yeah.
That's it.
So on the inside of the panel, we have the same kind of configuration. So the high voltage on the right, the low voltage is on the left. So the difference here is that after we go through the control transformer, now we have some additional stuff going on in the control circuit because we have PLC and we have some additional relays and fuses to protect it. So we got fuses here on the control transformer that are on the door, hopefully. Yes, these are. And then we have some additional fuses that protect the PLC touchscreen here. Okay, so that's like, back to that same thing. If you have power coming in, but you don't have control power, fuses are going to be a good spot to start. A little bit different, kind of motor starters here. The motor circuit's a little bit different. And I think these are back available. We were having some supply chain issue with these, so there were some Elite panels that went out without these. But these are a different style. They're an electronic, not a thermal overload, so they have a wider range. So what that allows us to do is build the panel to handle up to 32 amps, which is up to about a 15 horsepower pump. But it only requires 3 different overload ranges. That's probably 10 plus overload ranges with this style. So if we needed to, we could swap these out. And so we can pop out the overload range, and we can swap it out for a different one.
You're
Allows us
saying
to
Instead of
inventory
having to
one panel.
rewire and
You're saying overload. What do you mean by overload?
So overload protection is saying how many, that's that overload protection for the motor. So when the amp draw goes over what the rated nameplate is.
That's some
Okay.
That's some Iron Man stuff. There you just put it out, put it in.
So
yeah, so the overload is pretty much the amp draw on the pump,
yes,
correct?
yeah.
Okay.
So you dial these in to whatever the nameplate, the full load amps, that FLA on the motor is, and then it'll give you that safety factor built in. So same thing, these are going to trip to protect the motor, and these will actually, they have a little indicator on them when it does trip. It'll tell you if it's the overload or if it was a direct short. It caused the,
How does it let you know?
the little indicator right here, it moves from like 0 to 1, and then it goes red if it's a direct short.
So it's red if it's direct short.
Yeah, I believe it turns red if it's a direct short, and I think it says 0 or 1 if it's overload.
You can tell when you turn it on. Yeah, because at instant, yeah, but if it's a couple of seconds, then it trips, then you know it's stuck on the remote. And we should move it with the amp. You got your little clamp with the amp.
So it will at least try like a garbage disposal.
Yeah, it'll try.
And then,
it'll
and
hum
then
for a
that's
while.
when you know something's
So the other thing that these panels can monitor are seal fail and high temp. So the high temp is going to be just an output from the motor that's part of the wiring that's going into the panel. And really it's just kind of a monitoring alarm. The panel's not really doing anything. The pump's going to shut off with an internal thermal overload and it'll reset once it cools again. So that's going to come from typically that bottom float switch hangs up and it allows the pumps to keep running when there's no water in the pit. The motors need to be submerged in water to cool. So that'll shut off, and then once it cools down, it'll re-engage a lot of the pumps running. The seal fail comes into, in this case, this is a conductivity relay, so it's measuring the conductivity through a little sensor in the motor, basically how much water is past the seal. And seal fail is kind of a tough one, and I don't know what y'all's company policy is on getting the seal fail, and Jake can probably talk to this too, but it can be a nuisance alarm, right? It can fail, but it also could be a legit seal fail alarm, but the pump is still working. And with 10 horsepower and under, some pumps, the cost of a repair for you guys to pull it, take it somewhere to get repaired, and all of that can be, as much as half the price or more of a new pump. So whether or not it's worth it to pull it to see if it really is a seal fail to then repair it.
right here, right? At the adapter you come up?
So the seal fail, this is the seal, but this is actually the seal between the pump side that has water in it and the motor side that should be dry. Right? Like it should dry. It shouldn't have water, right? It might be an oil-filled motor, but there's a seal that on that shaft that protects the motor side from getting water in it, and there's the seal fail sensor is passive, right? So if you're getting water past the seal, then that's typically bad, right? But it also could just be that little tiny cheap sensor failed, or it could mean that you actually have some water in the motor, but it's still working, right? And so that's where it's kind of a judgment call. Is it worth it to pull the pump, to get it tested, to get it repaired, to put it back, or do you let it run to failure and then just replace it anyways? Because now you're going to have a new pump with a new warranty, all of that. So. Especially on the smaller pumps, kind of a judgment call, may not be worth you wanting to do all that for a seal fail. So, I don't know if you want to add anything on that.
That's a dumb alarm for me. I think of it. Moisture will activate. And, if it's sitting in this humidity or whatever, it collects moisture, they'll set the alarm. Those customers off. Run it for a couple of minutes, it evaporates and dries off. But sometimes it stays active. But the pump can run the rest 5-6 years with the alarm. Is the high check is the one you really got to worry about. And like I said, it could be a chance that it is leaking through and it is causing that alarm. But I've been in the field, I've been around people that fix them, cut it off, put it back together, and send it back to you. Because to me, it's just a dumb alarm.
So earlier you mentioned the pump being submerged.
Yep.
What's the two questions? What's the recommended level of your first float? And then what spacing do you
you recommend between each float?
Great question.
Depends your outlet, no?
So yeah, you're gonna have basically, you don't want to let the pump go more than halfway down the motor, right? So you have enough room, and you can leave it always underwater. That's great, but you can typically go down to about halfway on the motor if you need that extra pump down. But basically, you have from there to your invert, coming in. That's the usable space of the pit. And so
When
like
you
I
say
said,
invert, you mean the
like
inlet of the
the
water?
inlet, yeah, the inlet of the water coming in. That invert elevation coming down from wherever that inlet is in the sun. So that's your usable space. So ideally you want that first pump down range to be as long as possible. So it's, especially if you have a grinder, you want to have that longer pump down. So especially if it's an active pit, you don't want these things to start on, off, on, off, on, off, short. So EJ, I don't know if you have any recommendation on that, but just trying to get that first pump as much pump down.
I always do it like the weight ones, just one on top of each other. Like where the weight, select the other one on top of the weight. Now raise it up, second one. Second, raise it up, above the weight. So that's a good distance right there.
Gotcha.
So just do one at a 45-degree angle for it to activate.
Yeah.
And then the other one, so that gives you a good one time.
Good pump down.
And then again, like you said, it depends on the space of the pit. The height don't matter, it's just the diameter of the width. Because you never want it to rest on top of the pump and you're gonna lock it. It's gonna stay close. So if you set the offload above it and it's always submerged, it's okay. You just don't want it, like I said, it all depends where the inlet's at. You don't want it backing up. So sometimes it's a little tricky, but sometimes you can.
Yeah, that's a good point I was about to talk about just now. You really need to consider at what point they need to be alerted that this thing's getting full. Okay, so I don't want you to, don't put the alarm so high up that they get the alarm and then now their pit's already filling up and they got backing up coming inside their building. So you need to consider that when you're doing that. So if you got your inlet coming in and your pump's down here, they need to get to at least halfway when they're getting alarmed. Hey, look, your pit's getting full. You need to hurry up and change.
And hopefully you got one of these where it just turns on.
Yeah.
Yeah.
Well, let's hope so.
Yeah.
But you know what situations we're dealing with, guys, most of the time. So keep that in consideration with this alarm here. And pump 2. You don't want pump 2 kicking on when you're already up to the inlet of that. But you need to get it about halfway, a little bit over halfway on that one to where that pump 2 is kicking on. Actually, I'm gonna rebuttal what I just said. You need to be about halfway where everything's running. Okay? So if it gets halfway, then we need to hurry up and get that alarm going, and then everything's starting to pump on the second pump.
All right. So I'm gonna run through the touchscreen real fast, and then we'll hit on these floats, and then I'll turn it over to EJ. So on this screen, you're getting all the info of what's going on with the pumps, if you have any current alarms, what the run times are. So if you see those 2 run times and they're way off, that probably means that one pump is set to be the lead and not the other, right? So that one pump is just running all the time. You want to make sure that you want to have even run time on the 2 pumps. If we jump into the settings, you got right here, so instead of having an alternating relay, you do it through the PLC to be able to choose if you want pump 1, pump 2 to be the lead, or if you leave it in auto. So you would say leave it in auto unless you're doing service and you needed, if you're servicing pump 2, then you would put pump 1 as the lead. That way it's always calling pump 1.
But if you put it on auto, will it piggyback? Will it go?
It'll alternate each
Yeah,
time. So we'll go through the sequence and show you that. So you want to leave that in auto. The lag pump. So this is an alarm that we've added in. So we talked about how if in this traditional 4-float switch assembly, you don't get your high level alarm until both pumps fail. Okay, the lag pump counter on this one is going to keep track of how many times your lag pump came on. And so you can set that for as low as 2 or 4 or 5, whatever you want. But that's going to keep track of every time that your lag pump comes on in that sequence, and then it's going to alarm. So this is a good way that you can keep your high level alarm as the top float switch, but get an alarm if your lag pump is running. Okay, so we'll show you how that can happen. The runtime alarm. This is to protect against the bottom float switch failing. So we talked about if you go through this sequence here and this pump comes on and it just hangs up like this, there's nothing to protect that pump to turn it off if it's pumped down, and it's the only thing that's going to protect it is the thermal overload inside the pump. So what we have over here is this max runtime alarm, and depending on what the normal pump down is in the pit, you can adjust that. But once it hits that runtime, it's going to alarm and tell you, hey, the pump's been running for an extended period. It doesn't shut the pump off, but it'll at least give you an alarm that, hey, something's going on in the pit this time. So that's going to protect you from that bottom float switch failing. Or if you just have a major upset event, it's going to let you know that, hey, this pump's been running for a long time. And then on the floats, so on this one you can adjust between 2, 3, and 4 floats, depending on the application, without having to change anything. And there's different wiring that goes along with that. Okay. So the other thing I'll show you real quick before we jump into everything else is the test screen. So DJ will show you, talk through, testing floats with voltmeter, but this gives you a way to test them right here on the panel. So if you go from the home screen, you click on the test button right there, and you want to put the pumps into off when we do this, because the way that we build the high-level alarm on this panel is it bypasses the PLC, goes straight to a relay, and pulls in both the motor contactors. So it's still going to do that in this test screen. So real quick, I'm going to put this back to 4 floats so it makes a little more sense. So what this allows you to do is you can make like a long hook and reach down in the pit and flip up the floats, and you get feedback whether or not the float is working and where it is in the sequence. Okay, so if you were to, I'm lifting up, the lead pump on float, but if it wasn't flashing or it was flashing in a different spot, then you'd know that you have an issue with that float. Okay, so it's a quick way to be able to test these out to make sure that you're getting feedback and that they're in the right order. Okay. Alright, so we'll go through the 4 float switch real fast, and then I can talk through the 2 float if y'all want to see that one. But, so I'm going to use these float switches, or these switches here, just as it's easier than flipping floats. But these, like I said, you won't see these on a panel out in the field. So the bottom float switch has to come on for the whole sequence to start, right? And once we get to here, you're going to see the lead pump turn on, and it's going to stay on until the bottom float turns off. Next time the pit fills up, it's going to alternate. Okay, so now this is the lead pump, and it's going to do that each time. So if pit keeps filling up, the lead pump can't keep up, now our lag pump has come on. Okay, both pumps are going to stay on until the bottom float switch turns off. Okay. Okay. So let's say we go back to pump 1. Pump 1's working, so it's not a big deal. We're not going to hit the lag pump this time, right? It's going to pump it down. Pump 2 is just either clogged or it's not working right. So every time we get to pump 2, the pit keeps filling up. Okay, so now we're going to hit the lag pump again, and you can see we got that lag pump alarm because we hit the lag pump twice. So even though we never got to the high level alarm, it let us know, hey, you have an issue because your lag pump has come on too many times. Okay, so that's how we're able to leave the alarm, the top one, but still give an alarm if one of the pumps isn't working. Does that make sense? Yeah. All right, cool. So that pump's down and it clears. But if we go all the way up and we hit our high level, now we're going to get that high level alarm, and it's going to turn off once that top float switch goes down. Okay, but the pumps stay on until all the way down there at the bottom. Let's say this bottom float switch doesn't work, and we hit the next one, it doesn't turn the pump on, this one doesn't turn the lag on. But if we get to the high level alarm, it's going to turn on both pumps and give you the alarm. So you got that backup in case you have an issue.
I think that's I think that's a better system.
Is that just your elite system?
We build these the same way now.
Same way? Okay.
Yeah, but other manufacturers of a relay logic panel typically aren't going to build it that way.
Really?
So if your first float fails, you turn on both, you get a high alarm, and then the water starts coming down, when does it shut off?
So on the high level, if it's just running off the high level alarm, it's the pivot point of this top float switch that's going to determine the pump down range. So every time it's going to sit there and just high level, right? So you want to have a little bit longer swing on this if you can, because it's running the pumps, right? So anytime we're running pumps on a single float switch, you want to try to give it a little bit longer pivot, but you got to be careful you don't too much where it's getting stuck up in other things. But I mean, that's hopefully worst case. If you don't have a big pump down on this, at least it's going to keep the pit from overflowing, and it's just going to continually doing the waters.
What year did y'all start wiring the Spartan the same as they in that regard?
It's a great question. I have to ask Steve.
I don't know, but they're out there because like Transwestern,
3 years ago? Yeah.
Transwestern
Yeah.
don't have it, but a couple do already.
So, yeah, there might be a few that we built that went out without it, but I think most of them should have it. The Spartan series isn't that old for us. We've been doing the Elite series a lot longer. We developed the Spartan series when we started selling these. Cougar Systems has distributors in other parts of the U.S. and they asked us to build this panel. Like they wanted a panel like this to sell in their market. That's why we started making it. So here we've mostly been making the Elite.
Do y'all offer that chain system as well?
So yep, that's a great question. So this float switch assembly here, and it's we're missing the little tie off here on the bottom. But this is an upgraded float switch assembly, and it's the same manufacturer, Connery, but these are stainless steel, they're Teflon coated stainless steel floats with a heavy duty oil resistant cable. So if you have a pit that has high temperatures or has grease or anything like that, and it's just chewing through these float switches, these are a great option to upgrade. You're gonna get a lot longer life out of them. Okay. They don't work with weights, so you use this anchor chain kit. It's literally like a little boat anchor and stainless steel chain and shackles. And basically you can lay it out on the ground, set all your heights and your pivot points, and drop the whole assembly down into the pit. Okay, and then you can pull it all out if you need to adjust it. But this works great with these bigger float switches. We've had good success with them, like I said, in the really nasty pits. But there's a significant price difference between these and these, so that's why we don't do them on everything.
So what'd you say the difference between that one and that one is?
The price, or
What's the difference?
So these are plastic and these are a mechanical float switch. So inside there is a ball and contacts, and when it flips up, that ball connects the two contacts, and that's how you're making your float switch. These are stainless steel, Teflon coated, they're sealed, and it's still a mercury switch.
Okay.
So there are some mechanical.
Like liquid mercury?
Yeah. So when the mercury slides over, it makes the
You don't
contact.
even feel that one activated.
No, there's nothing inside there that you feel. Like from this one, you can feel the ball or hear the ball. And there are mechanical versions of these, but we typically get the mercury.
Okay.
The other thing that you'll hear when you're talking about float switches is wide angle and narrow angle. When you're doing a float switch like this from us, there's no difference in when it activates. Okay, they all activate the same way. The difference between narrow and wide, they kept the naming convention, but it's the narrow ones are made for control voltage, so they can't handle being wired directly through a pump. And the wide angle are pump duty, meaning you could do a piggyback float switch and run a small pump on it. Okay, but with these, the mercury ones, they really do have a wide angle and a narrow angle, meaning the narrow angle we would use for the first three because they're just doing controls. They're just telling the float switch or telling the panel that there's water there, so they activate on a more narrow range. And then this one would be a wide angle because we want that pump down, to be able to get a wider swing. So these, there is a little bit difference in the float switches, not a lot. These, we only buy the narrow angle for these anymore. Just
Do y'all have those readily in stock?
We do.
You
We
do?
probably have over 100 of these in stock alone.
And those? The other ones, do you have those in stock too?
We do.
Okay.
We do, and we do different lengths. So traditional lengths can be 25 feet. I think we stock up to 100 foot.
Wow,
lengths.
okay, sounds
But,
good.
If you can do a junction box closer than 100 feet, that's going to be ideal. But if that's not what's there, then that we have the longer cables if needed.
So I sell these separate? This right here?
That piece?
Yeah.
Ooh, no, haven't had to yet. I'm sure we could find one off an old pump if we needed to.
It'd be cool to mount that on something.
Yeah. So the other kind of, I think I hit on everything on these panels. The last thing I hit on these motors, especially kind of coming into hurricane season, see the difference between the cable that's on this type of Grumpus pump versus this one. So this goes straight down into the motor itself, and is attached to the stator of the motor inside the housing, and then it kind of has the potting to seal it. This is actually a cable that plugs into the motor, and so there's a seal between the cable and the motor itself. So when, obviously these are designed to be underwater, right? But if the whole room floods and you get water into the panel, you get water into the end of the SO cable here, and it will wick down eventually and get down into the motor. So on this one, if the water were to get inside this cable, it would go all the way down into the motor and run the motor.
Bless you.
But it takes some time. So if you do have a customer that floods, I'm gonna recommend that they change their pumps at the same time as they change their panel and everything else, because eventually their pumps are going to fail because they'll get that moisture down into the motor. With these, you can change the cable. You don't have to change the motor.
Man, just by looking at that, man, it looks expensive.
It is. I'm not gonna lie. These are expensive, but it's cheaper than that.
Why is it? What for a selling point with me? What's the selling difference? How
Between these two types of
Yeah.
pumps. So this is going to keep a moisture barrier between the cable and the motor itself.
Gotcha.
Right. So if the panel floods, then you just have to replace the cable. You don't have to replace the pump.
and the functionality of the pumps or the floats too, right? The floats function different on the Elite than they do on the Spartan.
Right. Right. So the selling points of an Elite panel over the Spartan or like a Relay Logic panel in general is that this has a lot more safety features built in and communication built in for the customer. So with this one, they're getting extra alarms on top of just a high-level alarm. They're getting that live pump alarm. They're getting the max runtime alarm. All of those are going to help design to protect their pumps and protect their building.
Do you think there's about a 25 to 50% price increase between the two?
I think it's about double, right?
Double?
To go from this one to this one.
Gotcha. Okay.
Get your own service bag with it.
Huh?
It tells you all
You get your own service.
Yeah, it has more safety.
Your direct line to
That's good information. I'm sure we're gonna. It's good to know how those floats and the pumps and
Yep.
everything work on that system.
Yeah, so this is going to cover you for a lot that can come up and happen. You get a lot of extra, like I said, a lot of extra safety features here. That's really what you'd want to push with the customers, and then this is going to protect you better than a panel like this, right? Ultimately, they do the same thing. They're going to pump down water out of a pit, but this one's just going to be able to protect the pumps.
Does it last longer, and does it come with a longer warranty?
So the warranty's the same. Good question. We have seen, I think, better life out of the floats on this one because we're doing 24 volts to the floats instead of 120 volts off of those.
It's not so much wear and tear on it. Okay.
Floats are rated for it, but it's a lower voltage.
Can you use those on a 24?
Yep. Yeah. Most of the time we're using these floats on this panel. Yeah, we just wanted to show off the fancy.
I like the chain. Yeah, it's fancy.
Yeah, it's a nice setup, no doubt. But like I said, I mean, it's significantly more expensive to use these floats. I mean, I think one of these floats is like costing.
So like you said, if we ever come across like maybe puffer swiving where we installed those floats, remember a long time ago? They get a lot of oil from cutting and threading.
Yeah, if these floats are getting eaten up or they're not lasting long, the high temp or the grease is really typically what does these
Heats them up.
and these can handle.
Good deal.
Before y'all make that decision, make sure y'all remember the size of the wire.
Yeah.
So you gotta make sure the conduit is big enough to be able to fit the wire on the.
Good point.
Yeah, and ideally, if you guys are, if it's a new pit or you're rehabbing it, you'd want separate conduit for the pump cabling and the floats and that.
6-inch pump, bro.
Yeah.
It's normally like 3/4,
That's make it
Alright,
tight.
then
Make it
put
tight.
it into one conduit.
It should
They
be a
never think about
standard. It
maintenance.
should be a standard 2-inch for every,
Nice.
underground conduit.
Right. 3/4 inch pipe. Okay. Did I miss anything? Okay. Any other questions? If not, I'll turn it over to this guy. Tell you the real stuff.
I guess what is the most common cause y'all get when y'all go on the field? When y'all deal with something?
Alarm.
Floats failing. Failing
I
floats.
mean, but what is the cause? Hey, the pump is not running, the pump ain't working.
Normally we don't go out there unless their alarm is on.
Yeah.
So what is the most common
The
problem?
floats getting hung up,
That ain't working.
or the floats aren't set right.
Okay, but the pumps aren't coming on.
Yeah.
Yeah.
The control's on, but the pump ain't doing anything.
But-
It shows the pump being on, but it's not doing
Right. And what operates the pump and auto? Floats. Okay, so when y'all get to the shop, to the field, and y'all put it on hand, the pump does come on.
No,
Sometimes
no,
it's
sometimes
not.
we had problems with the water and water.
Yeah. So there's a difference. If you bring it on hand and it does operate, that means everything's good in the pan. The overloads are not tripped, pumps can run, it's just out of sight. If for some reason you put it on hand and it don't come on, it's probably because overload is tripped. So that means that something's indicating that, hey, pump's locked up. So you reset whatever overload there is, if it's the switches or it's the button, and then you try it again on hand. And like I said, if it takes like 3 to 4 seconds for you retrip, it's jammed. So if it's a 3-phase, you can always change the polarity by switching 2 leads, and hopefully it kicks it out. But then again, it will call it
By reversing it, right?
Yes.
Yeah.
But there's a good chance to kick it out and then it'll activate again. But if you have your voltmeter, you can always check that based on the leads.
So you gotta get that.
And
If it's the right way, it'll run clockwise. If you flip those, you'll run it counterclockwise.
yeah, any leads. It don't have to be 1 or 2. Just
What's
any
the difference
leads on
between
the
one
board.
phase and three phase? Where you changing leads at on this thing?
For example, right here, this is your overload, this is your contactor. So whatever's wired here.
Okay, where you pump it?
Yes.
So right here, so you can change. You can go with
1 and 2, 1 and 3, 2 and 3. It don't
Switch
matter.
them?
Yeah.
and then we'll reverse polarity.
Yes. Recommend maybe do it like for maybe 10 seconds. But if it still trips the overload, then something's really locked up in there. And make sure when it does cycle, make sure it's set back to normal. Back to the same rotation. If not, it's gonna be running backwards. All right. But nothing happened because it's something you gotta pull out.
Yeah,
Pull the pump out and verify it.
And that's something that happened. That we had it was over the top, fish on the top, pick it up, get the air out, stuff it back in.
Yes. Right. And that's the other thing. But that's, if you set it back in there with water in there, more than you're gonna pull an air gap in between it. Like flipping a glass of water and putting it inside, you can have that air. So I always recommend everybody, like, hey, you can just pull it up, let it breathe, and you set it down, or just drill a little hole on the back of the pipe. Just like a 1/4 inch or whatever.
Bleeder.
Let it.
Okay.
Gotta be below the check valve. Gotta be below the check valve.
That's
So
fine.
especially if it's a pit, like a loading dock or something like that, where it can go dry, it's good to have one there so the next time the water comes up, it doesn't
That's
catch that
fine right
bubble
there.
again.
Yeah.
Right
Pumps,
before the check.
for example, this one has one. So it'll bleed air through there. So
Yeah.
sometimes when you turn it on, you see water splash out through there.
Yeah.
Some of the pumps have it, some don't.
Yeah.
So if you don't, before you stick it in there, you can always just drill a hole on the balloon itself, or y'all can just do it below, above the check valve.
Like that. Yeah.
Don't drill the pump. You hear that? Don't drill the pump. You hear that, Eric? All right, good. No, you heard me. Don't drill no pumps.
But you can always look and see, like I said, most of them do have it. Look for it, stick something in there because it can be clogged up. So unclog it. But like I said, don't do it, but if you can, like I said, just the balloon, not the hole. Never drill on the hole. So yeah, like I said, you stick it in there, you check your amperage, it runs low amperage, but you hear the pump running, but no water's flowing, it's many times airlock. Or check valve is clogged up, it's not open.
Yeah, so if it's under amps, it means the pump's spinning freely, but it's not moving water. So either it's got air or there's something clogged downstream.
The best way to always check and see if the pump is pumping, you pull it up. And you bring just above the water where you can see the discharge side, but this is still on the water. Turn it on, and you'll see it splash water against the pump, wall. Because I get a lot of those calls, hey, my pump ain't pumping. Go pull it up, see it, okay, it does pump. It's a constriction in the line. Either it's not sitting down correctly in the bottom, or something's locked on it. It's locked off the bottom. And there's been occasions that the line is blocked. So, what else I was saying? Okay, for example, this is your overload, like we said. This is your contactors. Not all of them look the same. They're all different. Of course, we have an overload up here. It's your switch that gives power, and also your overload that trips the pump in case I. You have another one that looks similar to these, and they have the overload at the bottom. It has a blue and a red little bud, and of course a little window that might have a little T for trip.
Yeah.
Always look into that and see if that is the trip before you go on and saying that the pump ain't coming on my hand.
Do y'all make those windows bigger?
Alright, so this is, of course, you know, each pump has a high temp. If for some reason the pump doesn't come on, even though you do have power on the panels and everything's good based on the, you know, you can't find out what the issue is. The overload's on the trip. So there's a high temp switch that is always closed. So there's times that it fails and it stays open. So on your high temp connections, it's pretty much tying your neutral to the contactor. So if that's open, you're not sending 120 to the contactor. So we put jumpers if there's no high temps, because I do get a lot of those. Hey, we just install a panel, but the pump doesn't come on at all. Or you replace the pump and the pump doesn't have high temps. But there's different pumps. Some come with high temps, some don't. So if it don't, all you gotta do is just remove that existing cable and put a jumper to it to bypass. So that will close that neutral. Alright?
What number is it on?
On ours, it's different numbers. But on all other people's systems, you'll still probably read it either motor temps or high temp.
I was gonna say, ours are gonna be labeled on the wireway, and then it's also up here on the door. But others may or may not have that on
So
there.
yes, if your pumps don't come on because you don't hear the clicking on the contactor, that's indicating is your high temps are not on there. They probably don't work with the pump and you can bypass it. He'll still activate the pump, but of course the safety feature.
Just to get them running.
Yeah, to get them running, getting the pump down. You can leave it bypass, but of course that's indication that it's gonna fail sooner or later. If it overheats, there's no protection. So, but it'll buy you time to get them a new pump, get the system up and running, or send one to get repaired, and whatever needs to be done to that pump to get it up to 100%. All right. And let me see, what else can I tell you? Of course, all of them have lights to indicate, you know, power, no power. If you don't see any power, more than likely your control fuse is blown or your high voltage event transformer or anything. For example, our green light indicates that the overload is good. If the overload is tripped, you hear the contactor still kick on, but the light won't activate. See? Nothing. Alright. So to reset, I'm going to turn it off and turn it back on. No lights, overload strip. Alright? But of course, that's not always. Not everybody does the same.
Yeah.
And of course, like this one, you have some have steel felt lights, high temp lights. You might not see them because maybe the fuse is blown. Or maybe not the fuse, but the light bulb. So you will always need to check your voltage to make sure that, you know, it is what you have. What else? Yeah.
Can you check if the float went bad with the voltmeter?
Yes, I'm gonna show you how to do all of that. I'm just going through it based on the things that go wrong. You show up and try to troubleshoot the issue.
Yeah.
That's what I'm asking. What's the most common issues that y'all run into besides? Mostly it's the pump doesn't run because the pit is full.
What's a good sequence to run through? As like you get there, what's a good sequence to run through to check out everything?
The main sequence, of course, you want to come in, check your incoming power,
Okay.
which would be either 480 or 230, three-phase, single phase. After that, of course, you know, verify what is, you know, are these tripped? Are they vertically with an angle or sideways? Trip is always at an angle. All right. After that, of course, you want to check your 120. Make sure you do have your 120. Make sure look and see if there are fuses. If there are, make sure your main power's off. Just check continuity between each fuse to make sure they all work. After that, of course, then check to see if your pump does come on hand. Then you start going through your floats. If you know, there's cases where you see the floats and the cable is swollen, more likely it's a crack in there, and you know the floats have a paper inside or some kind of nylon that what they was telling you, it starts sucking the water in it. So then this gets swollen and then starts causing a direct short. So if you start getting the control fuse being blown a lot, that's indicating it's either you can start disconnecting a few floats. I always go by that. If you don't know where the issue's at, start disconnecting the floats and verify to see if you still blow a fuse. Another thing will be your contactor, like coil. After so many usages, it will swell up and
where's that at?
internal of the contactor.
It's internal? Okay,
Yeah.
okay.
But if you go like, for example, this one, it got this on top, but some have like a little thing you can push in to activate the pump. Some people use a screwdriver to bypass everything, which is not something I recommend.
Yeah.
But if you can't do it, and, press it when the power's off, it's locked up, so that whole contact is replaced. So yes, sequence, checking on power, check your 120, verify that your overloads are not tripped, and then verify your flows work. If, like I said, got one of these, you have to get your hands dirty, check continuity between them. There's a chance you might get continuity between them, but yeah, you still keep, like for example, if you show up and your pump doesn't shut off, it's your off flow. But when you drop it, you can, on your voltmeter, you can see that it opens, but many times, it's an issue internally that you can't read it through the meter. You might need a mega meter, and it's still closed even though your meter can't read it.
What if you got a delay, like a 3-5 second delay when you flip the flow and you hear it activate, but then the motor doesn't turn on until like 4 seconds later?
Well, that's just a time delay on the system itself.
Oh, okay.
Yeah,
So
it's a timer. It's a delayed off delay.
So if something's delaying, what would be bad in the box? Nothing?
No. That's just a timer that is installed in the system itself.
In there.
Yeah.
Okay.
Because you don't want that. For example, it depends on the system itself. You don't want it to be off on. So as it turns off, it will 2 seconds more, and then it goes. And that's mostly on the C352.
We do that. We do the same thing on the on. Like if we're in a two-flow system, if we're using one pump to turn the pump on and off, we have an on delay with the float switch, right?
Yeah.
So like it takes a little time for it to turn on, so that way it's not bouncing.
Cool.
Right. So those time delays are probably built into the
easier on the system.
It's just to make sure that it doesn't barely turn it on and then go off.
Okay.
Barely turn it on and go on. It's like making sure that it's up before it turns on.
Because there's some, for example, these are mercury. So mostly, I don't know if you ever seen the yellow floats.
Yeah.
Okay, those are mercury. So those are narrow angles. So the float just has barely tilt and it activates compared to the 45. So that will be a time delay on that. Because if not, a wave, bam, start shattering and causing your contactors to burn out. Alright, so always recommend get away with the yellow ones and go with the green ones because of the angle. Alright. What else do y'all want me to come up with?
So does everybody understand the continuity that he's talking about?
The books?
Okay, when you're testing the system.
I'm not sure.
All right, good deal.
So who wants to be first with that moment?
Yeah, I've shown the floats and the fuses.
Yes.
DJ, you want a water?
Alright.
How you turn it on?
Alright, so. Alright, so you got your fuses up here, right? So you want to check continuity between it. So how do you set your voltage? Well, so you will put that across each other. You see your side. So that tells you it's good. Now you see we got power on the what do you call it? Pump. So let's say you shut the base power. Now you want to check continuity between the floats. Well, you still get continuity. So you have your, like I said, it's your off float, on float, light float, alarm float. So you want to verify if your off float shuts off.
These floats have a ground?
Yes.
Is that what it is?
Just do the big ones, yeah.
Okay.
So you would check continuity. Of course, you gotta verify which was your off float, which was your on float. A lot of old systems that come from the left to right, off, on, we do the opposite. We like to be different.
Yeah.
Okay.
Heck yeah.
So your off will be what terminal?
Your off is gonna be 7 and 8.
All right. So you would check up in between that. Okay. So then you flip it. Activate. So that way, if you don't have the screen, you'll know which float is what.
Oh, so this is so you're saying this is a 2-person job. That's what I'm saying. I'm just saying.
That's what I'm hearing.
There is time because we have a pit way out there.
Yeah.
Oh, they gotta go run. Like they can't hear it.
Yeah.
Or activate it somehow and hold it and then go check it. Can you do
You just wire nut
Alright.
on the floor. On the wires, disconnect the wires and just tie it to your wire nut. And then, depending on your
that's
hearing.
smart.
If you can hear it, you can hear it.
Yeah.
But yes,
Okay.
the other thing, of course, so you check your flows and all of that, right? So that's how you check it. Continuity. Now, to check your amperage, you know how to check your amperage. It's on the motor. Now, your motor normally, for example, this has black terminals, so it be hooked up here instead of directly to the motor. So, how will you check your amperage, your amps based on the pump?
You put it on the two of these, right?
No,
The two of these.
L2 and
whatever says 3 wires hooked up there.
Okay.
Where will you put your amp?
On either one, huh?
Either wire.
Okay.
It has to be just one wire. For example, how will you check your amp? See, that's you check your continuity and all of that there. Amp.
No, I already switched it over.
Okay, so this is your clamp.
Okay.
So you will run one cable through that. And if it's running, it will indicate what time it is. All right. Some people have the clamp. So just one wire. Not 3 wires, no, just one wire to show you how many amps is on that.
How would you test it if you don't have that little
One wire back
the setup like that? What would you put your wires on?
No,
So if they don't have this, if they don't,
no, they need one. That's what I'm saying.
Okay.
Your meter has to have a clamp.
We have it.
Yeah.
yeah, we do.
But you can get to this because it'll be in the box.
Yep.
Yes,
Yeah.
you can wire it in there.
It'll be in the
Same
box.
deal. Yeah, you still got the one.
Yes, it'll be here. You can also check like if your one of your cables of the incoming power, but mostly it's always best to check directly
On the black wires? Or?
Yes,
Okay.
black wire. I always have black wire, the bumpers,
Okay.
but others have black, red, and white.
And these are power right here, right?
These are your high temps. On our pumps, is your high temps
Okay, high
and
temps.
seals.
All right.
This is a dual motor, so it can be 230 or 480. So you will have to do the combination to make it to whatever voltage you have. All right.
So how can you tell if you put this together, if you use that, put it on there, what is this voltmeter supposed to do if it's bad?
No, it's not going to tell you that it's bad. It's going to tell you how many amps the pump is running.
Gotcha.
So say the pump is supposed to meet max is probably 8 amps.
Okay.
But yeah, you're reading 25. Motor's locked up.
Gotcha.
All right. Not as a bad motor. High amperage.
So when
That's
you
why
put it
this
on there,
keeps tripping.
what'd you get when you put it on there?
Not because the pump is
Not
on.
on, yeah, not on.
So that you have to run the
Yeah,
pump.
it has
the pump
to be
has to run.
on.
You have to run the pump while it's doing it. So
Yes.
meaning,
Not in the opposite. you have
meaning
to be
that
running.
the whole panel is hot when y'all are doing that. So be careful
This is
how you're working in the hot panel.
scared.
Yeah. So the one thing people do is this. Checking things like this. No spirit fingers, bro.
No spirit fingers.
Make a fist, 2 fingers grabbing your lead.
How does the spirit fingers go?
You can accidentally touch. So I tell my guys 2 fingers.
Okay. That makes sense.
Make a fist.
No teacup.
Safety.
Yeah.
Make a fist.
Yes, sir.
But yes, shake your amp with that. Other people have a clamp. You just clamp the first cord. Being line 1, line 2, or line 3, you just clamp it, and that will give you the readings. But make sure you put the pump on hands to be able to read it. And if it overamping, then you know it's something locked up.
Is there anything up here that I can put the clamp on?
Like I
For 3
said,
amps?
you won't be able to fit it, but you can try to like on those cords or the main incoming power one.
So as long as that amp number exceeds what the plate says,
Yes.
that's how you know.
Yes.
No.
No, you want
It has
to
to be locked up.
In other words, if you have this set at 10, and right here you're reading 30,
Yeah, that's too
And
much.
way beyond, and that's why that's
Then
tripping.
put it, then flip the lead.
Put it on reverse.
Trying to lock it. You know what I'm saying?
trying to
And check
reverse.
it.
Yeah.
Especially if you're getting that delayed flip, right?
Yes.
Yeah, if you're getting that delayed flip, that means that
Motor's locked.
something's going on. Look,
But if it's direct short, it's something else.
something's wrong.
Now to check your motors, Of course, I don't have these set up, but your motors, you check ohms on your pump. Okay, and you get 2 leads.
Okay.
Make contact with your leads, so you won't get it because these aren't tied in. But
Nick, hold that right there for him.
the
So you need 2 people.
Yeah, minimum
gotta
3.
Bundle them up.
You're one guy recording the phone. Yeah, it's got to.
You need 4.
One guy.
We gotta take a picture.
Alright,
The whole crew, go check a pump.
This one?
What I got?
Nothing.
you got it on ohms.
1 and 5.
Okay.
It's on on.
Nothing.
What normally on the 3-phase motor, when you check between them on ohms, you'll get either a 1.5, 3.5. So you check all 3, 1 and 2, 2 and 3, and all of that, and you should get even numbers. I mean, not even numbers, the same number on all leads.
Okay.
That's indicating motor's good.
Okay.
If you check it to ground and you get a little continuity, little sound, that means it's grounded. But like I said, sometimes you can't pick it up. You have to get a mega ohmer. It's a highly more sensitive electrical, and it gives you the readings. But normally, like I said, I don't have this really set up, but if you check between the leads, it should give you a number.
And that's just what it draws, right?
No, that's telling you the windings are good.
Yeah.
If you don't get anything, it's open windings, and that's why you're getting a short because it's touching the motor, and it's tripping your overloads and all that. All right.
Okay.
Fuses. Remember, these are also fuses. There's a little one. To get fuses, you just pull it down. All right, don't try to snap it off with it. Just pull it down. But if you see a little red light in the center, it's a blown fuse.
In the window, or
Yeah, it's just a little LED.
Yeah.
So just to replace it, pull it up, push it out, and put the new one in, and then just snap it in. All right. If this one trips, blows or whatever, it's a 120. That's your control side. So it's either, like I said, many times, it probably be on this one. It could be a PLC issue or something. But if it's 24 volts, it could be a fuse, or that float, or your contactor itself.
And they got a label too, huh?
Yes, sir.
As to how much voltage is running through each wire.
Yes.
That's what's up.
The wires, yes. 24 volts A, and of course 120. The 120 only feeds the manual side of your HOA switches and the power supply.
I gotta say, I like the way y'all upgraded y'all's all this.
Yes.
It's more labeled and detailed.
Yeah, it's easy to trace the wires.
Yeah, it's pretty cool.
All right. Pumps. When y'all install pumps, if you do a small horsepower pump, say 2 horsepower, there's a high possibility that when you pump it or turn it on, it will pump.
Yeah.
So you got to make sure you always check your rotation outside of it, because it be running backwards, and then before you know it, the impeller falls off. So
Falls
gotta
off?
Huh?
You say falls off?
Falls off.
Okay.
You run in reverse.
If you run a reverse for a long
So
time,
even in reverse, it will pump still.
it was
That means
like
that
2
means there's
horsepower
no good no
below.
more.
Huh?
That means there's no good no more, right?
If the impeller falls off,
Yeah.
yes.
Yeah.
Yeah,
That means
Then it's just
it's the whole thing.
rods
It's just a
spinning.
motor.
Yeah.
it'll unscrew itself, right?
Yeah.
Is what you're saying.
Yeah. So you gotta make sure outside you check the rotation. And the pumps usually have an arrow to indicate the correct rotation. This will be counterclockwise. I don't know about the Myers and all that.
And these are the ones I switched to get that to rotate that right? Oh, no, that one. Right.
Yeah, the power.
That's for the floats, okay.
Yeah, this is pumps. Gotta be right underneath the pumps. Like I said, we do terminals to hook them in. Sometimes they could just be hooked up directly underneath the contact.
Okay. And you can only do that with a 3-phase.
3 phase, yes. Single phase, you can.